The surprising problem that might delay Artemis. New Glenn flies again, but everything doesn't go as planned. Vera Rubin is finding so many asteroids. Voyager 1 has to shut down another instrument. All this and more in this week's Space Bites. Well, with the success of Artemis 2, all eyes are on the future. And the next big mission from Artemis is going to be this orbital docking test. So the plan is they're going to launch with the Space Launch System and then prove that they can perform all of the docking operations that will be required as if this was in orbit around the moon. Of course, you've got to get this right if you want to be able to have your astronauts be able to make their way down safely to the surface of the moon. So that's Artemis 3. Artemis 4, of course, this is when humans return to the moon as part of NASA's program. The plan right now is that this mission will happen in 2028 with either the SPHEREx human landing system, which is going to be a modified SpaceX Starship, or with the Blue Origin landing system, maybe a scaled down version of their Blue Moon lander. We've seen a lot of delays. I mean, it used to be Artemis 3, now it's Artemis 4, used to be 2024, now it's 2028. But there's another issue that could also cause delays with the Artemis 4 mission, and that is the spacesuits. And so last week, NASA released an audit of the state of their spacesuits program. And if you haven't been following this, back in 2022, NASA announced that they were awarding contracts to two companies. There's Collins Aerospace, which has a ton of experience in developing spacesuits, and a company called Axiom Space. And Axiom Space is relatively new, but they have lots of aerospace engineering experience. They're working on a private space station in conjunction with NASA and had put together, I guess, a really great proposal for the spacesuits. And not just from Axiom Space, but they had signed up a lot of great partners like Prada and Oakley to help build these spacesuits. And we've actually seen demonstrations of what these spacesuits are going to look like and how they're going to operate. And NASA wanted two different kinds of spacesuits. One for the International Space Station and another for the upcoming moon landings. So Collins would work on the one for the International Space Station and Axiom would work on the one for the lunar landing. But partway through the process, Collins realized they were getting too far behind. They weren't able to pull this together. And so they withdrew from the process. And NASA had set aside over $3 billion to develop these new spacesuits. And in this new audit, it said that the spacesuits might not be ready in time for this 2028 landing. In fact, they might not be ready until 2031. Now, that is not the final answer on this. We heard Jared Isaacman say that, in fact, spacesuits were well on track and would absolutely be ready for the 2028 mission. And as I said, we have seen demonstrations of these. Axiom Space has said they've had 900 hours of testing with the spacesuits. So it really seems like something will be ready to fly. But it's interesting, you just wouldn't think about all of the tiny pieces of the puzzle that need to come together for this whole mission to work. And in this case, maybe it's the spacesuits that will be the challenge, but we'll see. Now, speaking of missions to the moon, when we talk about reusable rockets, you're very familiar with what's happening with SpaceX, of course, with the Falcon 9 rocket, with SpaceX Starship, and also what's happening with Blue Origin. We saw all of the missions with the New Shepard. We've now seen 3 launches of the Blue Origin New Glenn rocket. We're seeing that reusable rocketry is now taking over the mainstream of space exploration. And China is catching up quickly. And last year we saw a reusable rocket attempt from a company called Land Space. They're developing a reusable rocket called Zhuque 3. The rocket came in a little too fast and exploded on the launch pad. And then we saw another test from the Chinese Space Agency with their first stage booster, which is going to be part of the upcoming Long March 10 rocket. And that did a soft landing in the ocean, sort of demonstrating that they're almost ready for a reusable rocket. They didn't actually catch the booster, but just in the same way that we've seen the SpaceX Starship soft land in the ocean, they're demonstrating that they can slow to a stop and land in a predictable area. So a reusable catch will probably happen relatively soon. And China is still experimenting with different ways they're going to try and catch the first stage booster. One is sort of this more traditional propulsive landing that we've seen with Falcon 9. But they're also still looking at a way of catching the booster with a kind of net, or essentially with cables. And this is actually an idea that SpaceX had originally considered and then had abandoned quite a while ago. And so now China has released a new 5-meter wide composite propulsion module. And this is going to be an upper stage component of the Long March 10 rocket. This matches the 5-meter diameter of the Long March 10. And of course, the Long March 10 is being developed to carry the two components of China's space exploration plans. You've got the Mengzhou crewed spacecraft and the Lanyue lunar lander. These will both launch on Long March 10 rockets and then meet up at the moon. They will dock, and then the taikonauts, which is the Chinese name for astronauts, will go down to the surface of the moon and then come back up and then return to Earth. And this component only took them about 7 months from when they made the initial request to when the final version of the upper stage was complete and they're ready to do their testing. So they're moving very quickly. Has a lot of composite components. The Chinese engineers said they had about 60% composite components, which of course decreases the launch weight. And it's kind of interesting how this is a different tact on what SpaceX did with the Starship. They were originally looking at building a composite upper stage and then switched gears and have gone for this stainless steel. And so it'll be interesting to see which of these actually works out in the end. But China's catching up quickly, and we will see what happens in the coming months as they do more tests in preparation for flying to the moon. And we got a story about this from Andy Thomaswick. I mentioned that we saw the third launch of Blue Origin's New Glenn rocket. This happened on Sunday. Let's talk about the rocket first, because that went fairly well. Now, this was using a reused booster from the previous launch, which had been used to launch NASA's Escapades spacecraft to Mars. They reused the same booster, but they put on new engines. The engines are going to be used in some future mission. And so we've already got this very rapid reuse. I mean, how long did it take for SpaceX to start reusing boosters? They're using the first stage booster right away. And the launch went well, and the booster detached and returned and was recovered again. And if you were watching the live stream, they were really focused on the landing of the first stage and even shut things down after the completion of the first stage, sort of forgetting about the actual mission itself. But the upper stage did not work very well. The upper stage was carrying a communication satellite from a company called AST, and their Bluebird 7 satellite is this gigantic communications panel. It's 223 square meters across, or about 2,200 square feet, a gigantic bright object in the sky that would then relay communications from the ground to other locations. It was supposed to be flying at an altitude of 460 kilometers, but we learned that the upper stage put it into the wrong trajectory. It didn't reach its full operational altitude. And AST said that the satellite's orbit was too low to sustain operations and that it'll have to be deorbited. So I guess they're going to be turning to their insurer to get their money back to do another launch. But they've got a ton of these things launched. They're hoping to have 45 of these satellites in orbit by the end of 2026. Although they didn't launch number 7, more of these are going to be going up pretty quick. And I gotta say, I'm quite impressed at how quickly Blue Origin has been able to reuse this single booster. It's as if they only have one and they're just going to reuse it. I guess that's savings for rockets if you only have to build one, but no, they have a bunch more in the works as well. Well, it looks like NASA has to shut down another of the Voyager 1 instruments. This time, it is the Low Energy Charged Particles Experiment, or LECP. And this instrument has been continuously operational for 49 years. Now, it measures how low energy charged particles, including ions, electrons, and cosmic rays originating from our solar system, interact with the galaxy. And so this has helped to measure the structure of the interstellar medium, how the solar system interacts with the combined solar winds of all of the other stars in the Milky Way. Now remember, the Voyagers are equipped with radioisotope thermoelectric generators. These are decaying chunks of plutonium on board. And over time, as the plutonium decays, it gets less and less heat over time, which produces less and less watts of power. And so every year, both of the Voyagers lose about 4 watts, and they only had a few hundred to begin with. So they're getting much lower on power these days. And so during a planned maneuver earlier this year, NASA engineers detected that the power power levels on Voyager went down significantly. And this was concerning because if the power actually runs out, then they would have this very complicated process to kind of bring everything back online. And one of the concerns is the keeping the electronics warm enough to continue their operations. And so in order to make sure they still have enough energy to continue the various science operations, they shut down the power to this one instrument. And so now Voyager 1 has two remaining science instruments, one that can measure plasma waves and the other that can measure magnetic fields. And of course, Voyager 1 is almost a light day away from Earth. And so when you're sending messages back and forth to the Voyagers, you have to take over 23 hours for your signals to reach the Voyagers and then 23 hours for their reply to get back to us. It must be a very anxious process to communicate with the Voyagers. Now, NASA is planning a very ambitious energy-saving fix for the Voyagers. They're going to swap out all of the power devices that are using high energy with versions that use low energy. And they do this all at once. They're calling this the Big Bang. And if they're able to do this, then that should give both the Voyagers longer operational time because they will have switched various components on board to the lowest possible versions of them. And so that will allow us to communicate with them for many years to come. But still, prepare yourself emotionally for the end of the Voyagers. That day will come, and it will happen in bits and pieces just like this. Eventually, NASA will decide it's time to shut them down. So we are now fully into the age of Vera Rubin. So how is the telescope doing? Well, as you can probably guess, it is a discovery machine. Every night it is observing about 700,000 things that changed in the night sky. New supernova, moving asteroids, comets, things like that. And in fact, we saw a new paper that came out that said that they've found 11,000 new asteroids in the solar system so far. And this is over the course of about a month and a half's observations. In addition to the 11,000 new asteroids, they looked at 80,000 previously known asteroids. But what I think is really interesting is that they found 33 previously unknown near-Earth objects. And these are the kinds of objects that can cross the Earth's orbit and could potentially strike the Earth in the future. And so knowing where all of these near-Earth objects are is really important. They were able to find 380 trans-Neptunian objects. So these are objects out in the outer solar system, in the area around Pluto and Neptune. Of course, this is the kind of place you're going to be looking for Planet 9, whatever is that larger object in the outer solar system. So Vera Rubin is absolutely able to look out into that region. And some of the objects are in the most distant ever found. And what's incredible is that this paper was just working with initial engineering quality data. So it is still delayed behind all of the observations that are happening right now. And this was the story by Matt Williams. Every week we do a vote on our channel where you tell us what you thought was the best space news story of the week. And the winner last week was the most detailed 3D map of the universe. So thank you everyone who voted. Now, of course, we're going to put this week's vote into the post tab here on the YouTube channel. So if you're watching this episode and you want to contribute, lend your voice, go into the post tab. You should see this poll, vote, and then of course the best chance to see these polls in the future, subscribe to the channel, click on the notifications bell, obey the algorithm. Mars is cold and dry today, and it's blasted by radiation from the sun and cosmic rays, but it was probably warmer and wetter in the ancient past. But did it have the raw ingredients for life? Could it preserve whatever life forms ever existed on Mars so that we could find them today? So NASA's Curiosity rover was exploring a region in Gale Crater with its Sample Analysis at Mars instrument, its SAM instrument. And it found 21 organic compounds in rocks. And 7 of these have never been seen before on Mars. Of course, there's still no way to know if these organic molecules have a biological origin or a geological origin. You can get organic molecules from completely inorganic sources. And the samples were found in clay-bearing sandstones that are probably about 3.5 billion years old. Now, one of the most interesting of these organic molecules is called nitrogen heterocycle. And these are rings of carbon atoms that contain nitrogen and are considered to be a precursor to DNA and RNA. And I think what's really important here is that these chemicals are being found on the radiation-drenched surface of Mars. And yet, even though they've been weathered and available to the surface for who knows how long, Curiosity was still able to detect them. And so if there are any signs of past life on Mars, even life that was there billions of years ago, it could still be detectable from observations at the surface. So either in the samples that, say, Perseverance is collecting and will one day come home on some Mars sample return mission, or when future human astronauts go to Mars and they roam around on the surface and take samples and bring them back to their lab, we should be able to find out whether or not there was ever life on Mars. We've got a story about this from Evan Goff. Now, with Vera Rubin operational, it's time to think about the next great flagship mission that we're all excited about, and that, of course, is the Nancy Grace Roman Observatory. This is a telescope that has the same size mirror as the Hubble Space Telescope. In fact, it was an old surveillance telescope that was delivered by the National Reconnaissance Orbiter to NASA, which was then repurposed into Nancy Grace Roman. But it has that same size mirror as Hubble, but it has a much wider field of view and an enormous camera system. In fact, Nancy Grace Roman can take a picture that there is no screen that has ever been made that can reveal the entire picture. There's that many pixels on the screen. And it's going to be viewing in infrared, and it's going to be mapping out the cosmos at the largest scale, helping astronomers understand the influence of dark matter, dark energy at different times in the universe. It also has a coronagraph that's going to allow it to see Jupiter-sized worlds orbiting around sun-like stars. Now, we're not going to be able to see Earth-sized worlds, but this is a step in the right direction, getting us towards that habitable worlds observatory. And originally, Nancy Grace Roman was due to be launched no later than May 2027. But it turns out they're ahead of schedule and they're under budget. And if all goes well, they're hoping to launch the telescope in September 2026. So just a few months away from now. It's been going through a bunch of tests, and next it's going to ship out and go to the Kennedy Space Center. And then just before September, it'll be packaged up, put into its rocket, and it'll be launched on a Falcon Heavy rocket in September. I can't believe, under budget, ahead of time. It's so cool. And now we've got a couple of stories about mapping the sky. First up, we've got data from NASA's SPHEREx mission. And this is a mission we've been talking about quite a bit. It has this really unusual infrared instrument where it's able to take images of over 100 different colors in infrared at the same time. And it's scanning the entire sky from space. It's building up a map of the entire cosmos every 6 months. It's also looking for regions that contain organic molecules and water ice. And one of the big questions about this is, in star-forming nebulae, where new stars and new planets are forming, we know that there are reserves of water and organic molecules, but are they available at the same place at the same time to be able to come together to form habitable planets like the Earth? And so SPHEREx has been mapping out a couple of these regions. One of this is called the Cygnus X star-forming region, and another is the North American Nebula. And many amateur astronomers have taken pictures of the North American Nebula. And so they found large amounts of water ice, carbon dioxide ice, these organic molecules, but they didn't find that there was a lot of overlap between the regions in these nebulae. So the mystery continues. Got a story about this from Andy Thomaswick. And then check out this picture. This is really cool. This is the entire sky seen in X-rays. X-rays are photons, but they have very high energy. They are characteristic of hot regions in the cosmos. Think about the kinds of hot gas that surrounds galaxies, flares off of stars, and some of the energetic particles that are coming from the sun. One of the challenges is that the sun is putting off so many of these high energy particles with its solar wind that it's really hard to disentangle what is the solar wind and what is the X-ray background of the entire cosmos. If you could get outside the solar system and look all directions of the sky and map out the X-rays, what would you see? We got this new image that came from the E-Rosita instrument, which is on board the Russian-German SRG observatory. Gathered its data back from 2019 to 2021, and then it was shut down because of the invasion of Ukraine. We've got this combined image that shows the entire universe that also includes the X-rays inside the solar system. But then astronomers were able to disentangle them. So you've got just the background of the cosmos and just the influence from within the solar system. It's a cool picture. Got a story about this from Matt Williams. I hope you're enjoying this episode of Space Bites. Now, You had to probably see an ad at the beginning of this episode. You might have to see one at the end. We've specifically removed all of the ads at the middle, so there are no interstitial ads in the middle. But still, there's more ads than we want you to see. But there's a place you can go and watch our episodes with no ads at all. Of course, that's over on Patreon. Now, I'm not trying to sucker you into becoming a patron. You can watch this for free with no ads. You can be logged out, incognito browser if you want, and still watch this episode. And of course, all the stories that we're covering here on Space Bites is just a fraction of all of the stories that we are writing on Universe Today. Every week, we cover kind of 30 to 40 stories about space. And we only have time to cover just a handful here. But if you want to stay on top of all of the stories that we are covering at Universe Today, you should sign up to my weekly email newsletter. I send it out every Friday. I write every word. It's completely free. There's no ads. Go to universetoday.com/newsletter to sign up. I'm going to talk about the level of complexity that we set for the interviews. But first, I'd like to thank our patrons. Thanks to Abe Kingston, Andrea Pedretti, Bear Lake Roofing, Brian Bodie, Caradwin, Chuck Hawkins, Commander Bielek, Dark Finger, Dave Giltonen, David Matz, Evan.pro, James Clark, Janice Smith, Jeremy Madden, Jim Burke, Jordan Young, Josh Schultz, Marcel Smith, Michael Purcell, Nordspace, OneStepForAnimals.org. Please follow my nephew at VBrick6994, Ring Kaidig, Richard Williams, Sean Sargent, Stephen Foundland Munley, Team 49, Telescopes Canada, Vlad Cheplin, Wolfgang Klotz, and Zeldaborg Galactic Defender, who support us at the Master of the Universe level. And all our patrons, all your support means the universe to us. So I got this comment on the recent interview that I did about the lack of supernovae here in the Milky Way. From Monty Palmer, very poor explanation of supernovae. He expects everyone to be an astrophysicist. I've talked to a lot of people who watch my videos, and I've gotten a lot of feedback about how we set the levels for what we do. There's a lot of people that the question shows are their favorite thing. And the question shows are very introductory. You know, if you watch enough of the question shows, you're going to see the same questions over and over again. You're going to hear me setting a level that is going to onboard people into having a better, deeper understanding of space and astronomy. That's important because people have questions. They want to be able to bring themselves up to speed. And I think, you know, one of the best ways to just start to understand the entire landscape of what's going on in space exploration and astronomy and cosmology and all that is to just immerse yourself in what's happening. And over time, these concepts will start to register in your brain, and you'll read some news article and go, I understand this entire thing. How cool is that? But there is a more advanced level that we're also trying to deal with. And on the channel, that is the interviews. And so when I approach the interviews, I am assuming that the audience is very knowledgeable, that I don't need to have my guests explain what an interferometer is. I don't need to have them explain the rocket equation or exoplanets or, a lot of concepts so we can get to the meat of what it is that they are discovering. If I feel like it's set too high for the audience, then I will ask some questions or try to explain it in my own words or try and qualify it. But I am not pulling any punches. When I am conducting the interviews, I am asking the questions that I genuinely have about their research. It is not me trying to sort of go through a set list of questions that I know that they're going to be able to answer. I know it's going to be entertaining to the audience. I am satisfying my curiosity at the level that I can comprehend it. And I know that you can too. Many of you can as well. But it's never going to be the right level for everybody. But the feedback that I've had is that people really enjoy the complexity of the interviews and they appreciate that it's not being dumbed down. And so, I do the best I can. I set the level as best I can. Sometimes it works really well. Sometimes it's overly complex, especially if it's like a really specific topic. But I really try to sort of put myself into the shoes of the people that are listening at the same time that I'm satisfying my own curiosity, at the same time that I'm trying to understand what is the new piece of news that is being announced. So I know it doesn't work for everybody, but hopefully it works for a lot of you. All right, we'll see you next time.